Again, welcome back to C++ programming language course. This lecture covers the selection statement in C++, also known as decision control structures. This is Unit 3, lecture number 1. So our main objective in this lecture is to learn how to write a program that, again, can make a decision. So an example given here in Unit 2.1, we wrote a program to find the area of a circle. So we ask the user to enter the radius, then we find the area of a circle. Now, if the radius value is positive, then we are going to get the correct answer for the area. But if the radius value is negative, then we are going to get a wrong answer or invalid result. So in this section, we can use the selection statement and tell the user if he enter a value less than 0, which means it's a negative value, we are going to prompt him to enter a positive value. So we are not going to use the negative value. So that's the motivation behind these lectures. So our main objective is to go through all the 3 different types of selection statement we have in C++. We are going to start with the one-way if statement, then two-way if statement, then also multi-way if-else statement, and also nested if. And nested if means there's if statement inside another if statement. So often in a program, we always need to compare 2 values. Here, for example, such as if I is greater than J, or J is greater than I. So C++ provides 6 relational operators, also known as comparison operators, in table 3.1, which will be in our next slide. Now, most programming languages, including Java and Python, we use these 6 relational operators. So we have less than, and equal. Again, the 2 symbols, there's no space between. So you write less and equal together, no space. We also have greater than, or greater than equal, and equal. In C++, 1 equal sign means assignment operator, as we said in our previous lectures. Now, if I want to check if 2 values are equal, then I will use 2 equal sign, which is equality. So to check if a value is equal to some value, we have to use 2 assignment operator, which represent equality operator. So again, we have less than or equal to, greater than or equal to, then not equal to. Not equal to also is the exclamation point and also the assignment operator. No space between. There's no space. So example given here is 1 less than 2. Yes, that is true. Is 1 less than or equal to 2. That is true also. Is 1 greater than 2. That's false. Is 1 greater than or equal to 2, that's false also. Is 1 equal to 2, that's false. Is 1 not equal to 2, that's true. So these are the 6 relational operators we can use to construct the conditions. So we start with the one-way if statement. So the syntax is if a Boolean expression. Now, the reason why we call the condition a Boolean expression, because we have only 2 options. Either the condition is false or true. So anytime we have false or true expressions, we call it Boolean expressions. So that's the syntax. We're going to have a condition. If the condition is true, the statement will print. If the condition is false, then we're going to skip the statement. So example given here, if the radius is greater than or equal to 0, then we are good to go, which means the radius is at least a positive value or at least 0. So here we will say that the area equal to radius times power. Then we print the value of the radius. So the area for the circle of radius is the whatever area we have. So here we have a condition so that if user enter a negative value, we will not find the area of a negative value. But in the previous unit 2, whether the user enter a positive or negative value, we're still going to compute. So this is the flow chart. We have a Boolean expression in a flowchart, normally the diamond symbol is a decision symbol. So if it's true, we are going to again execute our statement. If it's false, we skip the statement and continue. Same thing apply here. If the radius is greater than or equal to 0, okay, then we can find the area and then we print the result and we continue. But if it's false, then we are not going to find the area. We skip it. Now, in our next lectures, we're going to discuss a loop which allow us to do some attacks over and over. So, for example, if we have this statement in a loop, if the user enter a value negative, we are going to tell him, we can tell him to enter positive value. And we can keep doing that until enter positive value. So we should take a note here. Outer parenthesis is required in C++. So for example, here, braces can be omitted if the block contains a single statement. So what they mean is that if we have only one statement, one single line statement, then we don't need a brace. But if we have two or more statements, then we need a brace, which we normally call the compound statements. Because if, for example, I have two lines of statements and I don't have the curly brace, what will happen is that only the first statement will affect the if condition. The second and the rest of the statements will always execute. It doesn't have anything to do with the condition. So again, that's the whole concept. If we have only one single statement, you can remove the curly brace. And also the outer parenthesis is required always. Here we haven't talked about logical operators yet, which will be our next section soon. So if we have only one condition, that's fine. We don't need a logical operator. Normally, we can use the logical operator, which is the AND. This is called the AND operator, and also the OR operator. AND operator means if these two conditions are true, then we are going to execute our statement. If one of the conditions are false or both of them are false, we skip, which means the outcome is false. So we use the AND operator again to combine two conditions. So let's see an example here. So again, we include our IO stream or the input-output stream using namespace. That's the standard library file. We have our main function. So the first thing we need is our input. We declare variable name number, and we ask the user to enter an integer because our variable is int, a whole number. So the user entered the number. And now here we are using a condition to check if the number is divisible by 5. So we say if the number modulus 5 equal to 0, that means it's divisible by 5, then we print high 5. So example will be 10 divided by 5, the remainder is 0, so it's divisible. If I enter 20, 20 divided by 5, the remainder is 0, so high 5 will print. Now if I enter 17, high 5 will not print. So the second also, we are checking if the same number is also divisible by 2. So for example, if I enter 10, the cout I5 will be printed. And also I even also will be printed because 10 divided by 2, the remainder also is 0. So it's even number. Now, if I enter 4, I5 will not be printed because 4 modulus 5 is 4, not 0. But 4 is an even number, so I even will be printed. The whole concept again is how we use the if condition. So here we can see we didn't use any logical operator because we have only one condition. So we state that again, the condition, we always use the relational operators. So there are some cautions we should take here. For example, when we write our condition, we shouldn't end it with semicolon. We know that in C++, always we terminate our expression or statement with semicolon, but a condition is not a statement. So we don't need a semicolon. Otherwise, we get a logic error. Here, this is not a syntax error. So the program will execute, everything will work. But now this, if radius is greater than or equal to 0 with semicolon means it's no more a condition, but rather a statement. So it won't have any effect on what we have in the parentheses here. So that's why we say it's a logic error, because syntax is okay. It will run everything, but it won't give us a good result. Also here, they said we should always, you can include empty body, but again, it's not advised. So these two, they are the same. They are the same. Because when you put, again, semicolon here, it means this is a statement. So it's like you have a condition. And again, here we have empty body. So empty body means if the condition is true, we are doing nothing. There's nothing. So here they say this mistake is hard to find because it is not a compilation error or it's not a syntax error. Also, it's not a runtime error. It will give you a result. A runtime error will be, for example, dividing a value by 0. The program will stop. It won't give you any result. The syntax will be okay, but when you run it, it will not give you a result. But logic error will give you a result which is wrong. So next is the if-else. So we call this the two ways. So we can see the if statement, we only have a condition. If it's true, we do something. If it's false, we skip the whole section of the statement, again, selection statement. Now here we have two ways now. If a condition is true, we are going to do something. Else, if the condition is false, we do the false case. So the else section will be some statement that will be executed if, again, the condition is false. So we can see the flow chart. We also have our Boolean expression, that is the condition. If the condition is true, we do something, the statement for true case. If the condition is false, we do something else, the statement for the false case. Also, we have what we call the nested if statement, which means we have if statement inside another if statement. Now, the way this works is that if I is greater than k is true, then we can go inside and check the next if statement. So if j is greater than k is true, then we are going to print the output here. I and j are greater than k. Now, if I is greater than k, but j is less than or equal to k, then this statement will not execute. The I and j are greater than k will not execute because if j greater than k is false, so it will not execute. And also, it will not execute this because it's already inside the second if statement. But if I greater than k is false, then it will execute the else section. So the else section will be executed. That's why here you can see we are saying that I is less than or equal to k. So if I is greater than k, the next we check is j greater than k? No, j is not greater than k, but already I is greater than k, so the else section will not execute. So this, in this case, no statement will execute it. Or if we like, we can put else. After if j greater than k, then we can put else inside the if. Then that means if this condition is false, the second condition will print. So this is also the next multiple alternative if statement. Now, if we have more than two conditions, so for example, here we are talking about grade, The score grade can be A, B, C, D, F. So we have almost 5 criteria or categories. So here we can say that if score is greater than or equal to 90, then we are going to say grade is A. Else, if score is greater than 80, we are going to say B. If it's greater than or equal to 70, we are going to say C. Else, if the score is greater than or equal to 60, we are going to say D. Else, we say F. So if any of the conditions, for example, if our first condition is true, then we are not going to test the rest. We just print grade is A, then we continue. So this is nested if else. The best way to write it is this form. They are all the same. You can write if, else, if, else, if, else, if, then else. It's more readable and more nicer to again understand that this. But another way also is that we can use only if. I can say, okay, if score is greater than or equal to 90, grade is A. Then if score is greater than 80, grade is B. If score is greater than 70, grade is C. Now, the reason why we don't use only the if throughout is that if the first condition is true, the second condition will be tested also. So for example, if students enter, let's say 91, grade A is going to be print. Is 91 greater than 80? Yes, so grade B will be print. Is 91 greater than or equal to 70? So this means if I enter 90 or 91, all grade A, B, C, D, F, everything will be printed. At least A, B, C, D, everything will be printed because we have conditions. So that's why the best way is to use the if, else, if. If, else, if any of the condition is true, let's say the score is 88, then the grade is B. That's the only one will be printed. C, D would not. So that's the example here again. Suppose the score is 70. We check is 70 greater than or equal to 90? No. So we are not going to print grade is A. Next we check is 70 greater than or equal to 80? No, we are not going to print. Then is 70 greater than or equal to 70? Yes. So we are going to print grade is C. Grade is C. Then we skip the rest. We are not going to check the rest number. So we continue. So here we say we exit the if statement if any of the conditions are true. One note also here is that the else clause always matches the most recent if clause in the same block. So what they are saying here is that, for example, these two, they are the same. See, I have now in Python, we know in Python, indentation is very important. In Java, C++, indentation is not, it's ignored. So for example, we can write, we have a variable ijk, we declare and initialize them. And now we say that if I is greater than j, and also if I is greater than k, then we say C out A, else B. It seems like the indentation is getting, what will happen is that if the first condition, if I is greater than j is false, then we are going to skip all these conditions. Now, this is the same as writing it here, but again, this is more readable. This is better. It's good to align the inner if else together, but it doesn't matter whether it's aligned or not. Python is very important. Python, this else will be going with this if. If I put it here, it means this if go with the outer if go with the else. That's in Python. But in Java, C++, we ignore them. So again, let's see this program here and see what will be printed. We have I is 1, J is 2, K is 3. This is our previous program. So now is 1 greater than 2? No. So this means we are going to skip. We are not going in. So we are going to skip here. Then we see the next one. So here we say nothing is printed from the preceding statement. Now to force the else clause to match the first if clause, you must add a pair of braces. Yes. So this condition here again, if it's true, that's good. We check this condition. If it's true, then this will print it. If it's false, then this will be printed. But we need to add another curly brace if we want, like now the way it looks. Now in this case, what we are trying to say in the previous year, if I don't have the curly brace as we have it here, nothing will be printed here because this if go with the else, this if, the inner if go with the else. But now we have the curly brace here. Here we are saying that this if, it doesn't have no